I'm back, and now we want to talk about plastic structures. So we said that when you subject a rock to a stress, one thing that it could do is it could break, and then it's going to make either a joint or it's going to make a fault. And then another thing we said that it could do is it could bend and behave plastically. So here's our first example. This is going to be a monocline. And so you notice what caused the monocline was a fault line underneath the ground. And so it pushed up part of the ground on one side, and then it kind of dropped down the rocks on the other side. So it's easy to see a monocline from the side view because it's just going to be something like this. Now, the reason why we call it a monocline is only one side of it is going up. Now, when the other side is going up, we're going to have a different word for that kind of a structure. So this is going to be called a monocline. So that's what it looks like from the side view. So what would you say it looks like from the top-down view? Well, it's going to be a series of steps, okay, kind of like a waterfall, so that you're going to have a layer of rock, and then it falls off, and then another layer of rock, and then another layer of rock. Well, if you notice, that's very similar to what it looked like whenever you had beds that were tilted and then going into the earth. So these are different layers that are being eroded away, and you can see that it kind of makes a series of steps that goes down. Okay, now let's compare that to an anticline and then a syncline. So whenever you have rocks that are bowed downwards like this, that's going to be called a syncline. So just think about when you commit a sin, where do you go? Okay, so you're going to go down. So this is going to be a syncline. Okay, then you also have anticlines. And an anticline is going to be like this. So it's going to be bowing upwards. Okay, and then you could have a anticline and you can have a syncline, and they could be dipping. So that, imagine if you were to take a rug and then tilt the rug so that it's pointing at an angle downwards. Okay, so what that's going to do is you see the difference in what it looks like from the overhead view to the sideways view. Okay, and so here we've got a syncline and an anticline. Okay, now where are the oldest beds in an anticline and in a syncline? So let's do this one here, and then let's change this so that it's both an anticline and a syncline. So here's the syncline, here's the anticline. Okay, now here's your oldest beds are going to be down here, and then the youngest beds are going to be up here. So that if we were to make a cut through it, okay, so that let's say that erosion occurs, with the syncline, the youngest beds are going to be in the middle, and the oldest beds are going to be on the outside. Whereas in the anticline, the oldest rocks are going to be in the middle, and then the youngest rocks are going to be on the outside. So that's how you can tell whether you're looking at an anticline or a syncline. You look at the rocks, you measure which ones are the oldest ones, and then you can figure out whether it was an anticline or a syncline. So from the air, the horizontal anticlines and synclines are going to look like hills. And it all depends on which rocks are the most erodible, as in what it eventually looks like. And then when it's a dipping one, you'll notice it, I don't know, teeth, okay, so that you'd have something like this where it goes in and then out, and then you have another one that is doing something like this. So that's what it's going to look like when it's dipping. And an excellent example of that is the kinds of anticlines and synclines that you have in the Appalachian Mountains of the United States. Okay, related to anticlines and synclines are going to be domes and basins. So if you want to think about it, a dome is going to be a three-dimensional anticline, and a basin is going to be a three-dimensional syncline. So if you look at it from the side view, you'll notice that the dome is going to kind of look like a anticline. If you look at the basin from the side view, you're going to notice that it's dipping down, so it's going to kind of look like a syncline. From the top-down view, it's going to look like circles within circles. And just like with the anticline and the syncline, you can figure out which one you're looking at by looking at, are the oldest rocks in the middle, or are the oldest rocks on the outside of the structure. Domes are very important because they could trap oil. And so a lot of oil companies will drill into a dome to get at the oil that is somewhere trapped underneath it. Basins are very important because sediments accumulate in basins, and so sometimes ores could accumulate there, like for example iron. Later we're going to talk about the red beds, and red beds are large amounts of hematite, and it's rusted iron that we dig up out of the ground, and then when we smelt it, we can get the iron out of it, and so that accumulates in basins. So these are very important for economic purposes. Okay, we're going to take a break, and when we come back, we're going to talk about how do mountain belts form.